Hello guys, welcome back to my channel, Memo African Motives. Still working on engineering science and 2, which is working on the question paper which was actually written in August 2021, which is we must be focusing actually on energy and momentum. So we want to see how we were supposed to actually answer these questions under energy and momentum from this question paper. So guys, if you're new, you can consider subscribing so that you become part of the family Memo African Motives working on engineering science and 2 past papers and so forth. So we shall quickly rush through the question paper and see what we were given in this case, which is on question number 3. We are given energy and momentum. So the first part or the first question was to define the potential energy of an object or body. An object or a body, which is 2 marks for that. Okay, so we know that potential energy, that's the energy a body is going to possess when it is just at standstill, when there is no movement at all. So that is potential energy. Okay, that is the energy a body or an object possesses, or the one that it has as a result of its position, or there's supposed to be its position there. That is when it is at standstill, when there is no movement. There will be no movement at that point. The moment that there is movement, we are now talking of what? Of kinetic energy, but this is just potential energy that we are talking about here. Okay, so that was it for this one. And on 3.2 we are given that an object with a mass of 5 kg is falling from point A at the top of a building, which is 8 meters from the ground at C, at point C. The object passes point B, which is the first floor of the building and is 2 meters below point A. All right, they are, I think, representing this in terms of a point. The line is going to help us because this is something you have got an object which is actually falling from, which means we are representing or talking about a vertical line there. So this is where it is at the top, and that is our bottom here. So this is top. Okay, and here we are at the bottom. So what is happening here is that we are given the mass of this object is 5 kgs. Okay, so you can just write our mass here, which is 5 kgs. Then from point A at the top, which is 8 meters high from ground at C. So A is the one which is at the top, C at the ground. Okay, so this is our point A, this is our point C at the ground, which is at the bottom, but in between we have got a difference of 8 meters. That is the height from A to C. Okay, then the object passes point B, which is the first floor of the building, and is 2 meters below point A, 2 meters below A. So this is our A here. So we've got a point B that we are having at this point B, which is 2 meters from this point A, below A. So we've got 2 meters here. So if this is 2 meters below A, it also means we've got a distance between B and C that we are supposed to take note, because from A to C we have got 8 meters. This is the 8 meters that was indicated here from A to C. So from B to C we are going to subtract 8 minus 2, which is 6 meters. So that if we add 2 plus 8, you are going to 2 plus 6, you are going to obtain 8. Okay, so it's going to help us. Just write this, it's going to help you. Anyways, let's answer the first question, which is 3.2. 1. Calculate the potential energy of the object before falling. What is the potential before falling? Which means we are talking about when it is at the top before falling. All right, so this is 3.21. So we know that the potential energy before falling, that is the E at the top, which is mgh. So it's going to be mass, that is the potential energy at the top. So the mass of the object that is 5 times g. Remember, the gravitational acceleration is given as 9.8 times the height. So the height is the one from A to C when it is at the top, which means it's above 8 meters. So that's your height there. All right, so we are going to obtain the potential energy of 392 joules. Remember, this is energy. So that's the potential energy that we are having there, which is at the top. All right, something like that. Yeah. And I think it's clear from this part. There's if this one was just like a matter of substituting into the formula, just like that. But this question now is the one that I'm so worried about here, where we are given to calculate the kinetic energy of the object at point B. What is going to be this kinetic energy at point B? So take note, guys, that what is going to happen is that remember the relationship between the potential energy and kinetic energy, that the potential energy that we have here at the top is actually equivalent to the kinetic energy that you're going to have at the bottom. So it means if this object was going to move, actually to move up to C here, it was going to give us the same potential energy which it had at the top, which is 392. But now, because of this part here, it couldn't manage to reach the point. It is now at point B. So what is the kinetic energy at this point B? Which means we need to know the kinetic energy which was going to be used from this point up to this point. We need to know the kinetic energy that was going to be used. And the kinetic energy at the bottom, at this point, will be the same as the potential energy, which is at the height of 6 meters, because there's a height of 6 meters here. Remember, EP top is equal to EK at the bottom. That is kinetic energy at the bottom. So that is the concept that you're going to use. So it means that the kinetic energy that we need in this case at point B, so just write it at point B, is going to be the potential energy that you had at top, because this is the same as the kinetic energy at the bottom. But we are going to subtract now, because it at the top is same as EK at the bottom. So we're going to subtract now the potential energy, which is the same as the kinetic energy at the bottom, but this time it's at the top of 6 meters. So we are now talking about this one, which is at the top of, because we are saying at the top. So this is like this. Our diagram is now like this. This is where it is at B. And at B, it's above 6 meters. So we need the potential energy at the top, which will be equal to the kinetic energy at the bottom. So that is the idea then. So we are going to subtract the potential energy that we are going to have at the top, but at what? At 6 meters. P top there at 6 meters. This is at the top at what? At 8 meters, where we had the original one that was at 8. Now we are going to work with 6 meters. So the 2 is the one that was moved. So that is the one that we are subtracting, so that we remain with the kinetic energy. So we are going to remove this. That is the one that we are going to subtract. So we are going to subtract this, to remain, because we want to remain with this. We want to remain with this part. So that is why we are subtracting this one. That is why we are scratching this 6, so that we remain with the one at B, which is after 2 meters. Okay, so already this one is there, but this one we do not have. So you're just going to substitute EP at the top, which is the potential energy at the top, the one that we calculated. We got 392, if you're not mistaken, minus what is going to be the potential energy. Now take note, this one we got 392 here. Okay, so what is going to be the potential energy now at 6 meters? Remember, potential energy we say is mgh, so it's mass times gravity, but now it's times 6, so it's 5 times 9,8 times 6. So this time we're going to multiply by 6. Why? Because we're talking about height above this height of 6 meters. Okay, so Doing this, we are going to obtain 392. That's 392 minus, you multiply these two, 5 times 9,8 times 6, these 3, you're going to obtain 294. So this is going to give you 294. Remember, it's measured in joules, so you subtract 392 minus 294, which is going to give us 98 joules. So this is going to be the kinetic energy that we actually needed, which is at point B, which is 98 joules. So it's the difference between, or we could have maybe worked with the velocity, but yeah, it was going to be another working which you can use. But as you see, I always come with maybe simpler ways, simpler methods that we can actually use to answer these typical questions. So you just choose which one is best for you guys. So that's it for Mason African Motives. Till we meet again.